Now, how does the farmer intend to improve the soil structure? The farmer is intending to improve the soil structure by taking the advantage of the organic materials that are generated within the farming systems. You can see the chickens is being reared here, and these chickens, he has to keep the material from the kitchen here that is going to combine with those ones from the animal, from the residues or the products of the harvest or the remains of the harvest, which is being kept in the store, and this together with the animal manure, like having zero grazing here, is going to combine all this to make the compost that is going to use to improve the soil structure. Now, the farmer also has learned over years that the interaction between the above ground diversity and below ground biodiversity has got a positive impact on the ecosystem functions. The vegetation that will grow above the ground interact positively with the below ground biodiversity, which are actually in different functional groups, and each group functions differently to give specific ecosystem services which are utilized in the farm. Now, here, the area generally has soil structure which is compact, cemented, and generate a lot of runoff. Even though you are seeing the vegetation covering this place green, the soil structure is really deformed because of high compaction and cementation in the subsoil. What happens is that when it rains, like now it once rains, the water generates a lot of runoff because of low infiltration rate. And that water is found its way down the slope. Now, this farmer has put a retention dish here to harness the runoff water coming from the upper slopes. There are a lot of water comes actually through here, and this water is retained here, but it has got a slight gradient that makes it flow towards the end of this ditch, uh, so that the extra water can be discharged at non-erosive velocity towards the exit. Now, below the retention ditch, the farmer has grown trees, and also grass is generated under those trees. Now, this actually reduces the runoff speed from the rainwater which falls directly on this slopy area. So what normally happens is that when it rains, the runoff is actually checked by the vegetation and also the carpeted layer of grass and leaves, which in addition to checking the runoff, also is getting decomposed and enhancing the soil structural stability and formation that facilitate the water retention and also enable the water to stay within the root zone so that it can support the plant growth. But this water, which is coming from the retention ditch, is percolated into the soil profile and actually flows laterally towards the downslope. Now you can imagine that it rained last week. In fact, about not last week, but 2 weeks ago, and the water has dried from the retention ditch. But if you come down the slope, you still find that there's some flows taking place. These are the water which is actually oozes from the ground because it went into the soil through the interception by the vegetation, which gave the opportunity time for water to be infiltrating into the soil profile. So that water actually is the one which is now released slowly down the slope. It's here water on the ground. Now the bright spot in the other side of the farm is actually a grassed area, which is for grazing and controlled grazing. Now the manure is used for improving the soil structure, even under the vegetation that we are here. Now this water is moving down the slope, and You can see it's moving at a very slow velocity. It's coming from the ground. It's actually lateral flow which has saturated the subsoil and is now finding its way up to the on the surface to move slowly under controlled velocity. You can see there is no gully being formed because the water is allowed to spread within the grass. There is no concentrated flow in a channel as normally is a case of gully erosion, but it's actually allowed to permeate into the grass and spread slowly under the carpet down to the place where it is required to be at the time it's to be there. Now, as we move down the slope, I'm stepping on the shimmy of water. Now, you can't see it properly because it's spreading under the grass. Now, when it approaches the place meant for it, which is the bud, you can see now we have concentrated it in a small channel, which is grassed waterway, to move at a reasonable velocity into the water pan. Now, this is a water pan which is taking the water generated from the catchment area, which is vegetated, to intercept that water to be used for irrigation during the dry spell, to irrigate the crops, to take the advantage of the market window, which and also diversity from the common crops, which in this case is maize. So there's this area we are moving to is a place for controlled grazing, where you have some animals. This time round we have put them on the other side of the padlock so that they can graze there for some time. Then we shall move them here up here, and we use them for milk. At the same time, for manure is being used for improving soil structure. Now here, what I want to demonstrate here is very interesting. This one is a sprout which has deliberately been designed to facilitate the measurement of the flow. Now, we are talking about water productivity. When you talk about water productivity, the first thing that comes to your mind, how are you going to measure it? If you improve the water productivity, how do you measure it? Okay. Now, up there is the catchment area, which is a conservation area, and it is 300 meters square. Now, that area is generating water to be tapped in this water pan through the flows which are controlled, which does not cause any erosion. Now, when it comes down here, we have designed this water pan up to a certain level. It is designed in such a way that when the water reaches a certain level, the overflow comes through this sprout, and that facilitates measurements. You can be able to measure how much water is generated from the conserved area. Now, if you just put a measured water container and tap this water and time it, we know the rate at which this water is coming out from this sprout. Imagine it rained 2 weeks ago and the area has dried, but the water is still coming through the conservation catchment area, lateral flows coming out into the surface flow, coming slowly at controlled velocity and finding its way into this water pan. Now, what we found out is that the area, which is a 300 meters square, which we have reserved for conservation area, is tapping the water runoff more than the capacity of the water pan that we had designed here. That's why there is overflow, which we have left to move down the slope to find its way through grassway down the slope. But what we are going to do next is to dig this water pan deeper so that it can accommodate these flows which are coming from the conserved catchment area, so that we accommodate the full earnest runoff water and utilize for irrigation. Now, the area which we have prepared for irrigation is this side, which already the land preparation is going on, and we are going to use this water, pump it into the tank, storage tank somewhere there, and then divert it into the irrigated area to grow crop, targeting a market window during the dry spell. So the next time we are going to demonstrate how we are going to do that so that we can improve the water productivity, and how we are going to measure the water productivity in terms of revenue obtained per unit liter of water.